Okay, so what is the opposite of squaring something? Okay, squaring something is not doubling something, so the opposite of square rooting would not, or sorry, dang it, I just said it. The opposite of squaring would not be cutting it in half. It would be the square root, right? Because if I say 5 squared is 25, then the square root of 25 goes back to 5. So if I want to get rid of, remember, just like solving any equation, it's opposite operations on both sides. Remember, going back to solving regular old equations? If I just have a single squared piece and nothing else in the problem, that is when I can use solving by square roots. Okay? So if I have a single squared piece and no other variables in the problem, I'm allowed to use this method. If I have a normal equation like this, so if I pull this over to the side, if I have like x squared plus 3x, oops, I missed, minus 5 equals 0, I cannot solve by square roots because I take this square root to get rid of this x squared, I take the square root here, and I'm left with the square root of 3x. That doesn't really work, right? So if I have more than one variable in the problem, if I have an x squared and an x in the problem, I cannot use square roots. But all of the examples that we have here today are all solved by square roots. So there's an x squared and nothing else in the problem, okay? So let's look here. So how do I get rid of an x squared? I square root it, right? So I square root x squared to make it x. And anything I do to one side of the equation, I do to the other side. Okay, square root of x squared is x. What is the square root of 49?
7.
Remember earlier I told you guys that answer was not good enough?
7 or -7.
Okay, so let's think about this for a second. The square root is asking me what could I multiply by itself to get the number under the square root. So what number could I multiply by itself to get 49? You guys all said 7, which is correct. 7 times 7 is 49, so x does equal 7. But what else could I multiply by itself that would give me 49? Negative 7, because negative 7 times negative 7 is also 49. So I know you guys have all learned square root of 49 is 7. I understand that. I get that. Your teachers have always taught you, and they're not wrong for teaching you this, but your teachers have always taught you about the principal square root. Okay? That's the positive square root. It's called the principal square root. That's what we've always learned about in the past, but now we need to kind of expand our knowledge because we know that that's not really true. It's not just 7. It's positive or negative 7. And we denote that with just a little plus or minus 7. Okay? It's the same thing that you saw in the quadratic formula. Right? And that's kind of built into the quadratic formula because it's plus or minus the square root. It's built into the quadratic formula already. Okay, but from here on out, when we're taking square roots of stuff, we need to realize that it's positive and negative. Okay? So same thing here with square root of 100, or sorry, x squared equals 100. I take the, I don't know why that happened. I take the square root of both sides. The square root of x squared would just be x. And the square root of 100 is? Plus or minus 10. Plus or minus 10, because it could be positive 10 or negative 10. Okay, let's pull over and look at our other... Whoa. Whoa. Whoa, that's weird. Why did it do that? Hold on, I know how to fix this, if I can remember. Group. Arrange. Locked. Locked. Did that do that? Oh no. Uh-oh. Alright, I'm getting rid of it. I don't know how to do it. Okay, sorry. Okay, then square root of 75. What is the square root of 75 on your calculator? Remember, we're going to do decimal approximations now? I know the directions said leave it in simplest radical form, but we're not worried about that anymore.
8.66.
8.66?
So you can't be like 5 radical 3.
You could do 5 radical 3. If you still give me an exact answer with a simplified radical, I will take it. Okay, I'm just giving you the option now. You can use decimals if you want to.
Right.
So you said it's 8.66? So plus or minus 8.66. And just like Colin said, could I do 5 radical 3? Sure you can. Just make sure it's plus or minus 5 radical 3. Okay? All right. So I'm going to give you very little instruction, and then I'm going to let you try example 1. Okay? So my very little instruction for example 1 is isolate the square part and then do what we just did above. So isolate the square part, then do what we just did above. Okay? I want you to give example 1 and 2 a try. Okay? Just give it a try. If you're doing it on paper, don't write it in pen because we might make changes. But give it a try. Isolate the square part and then do what we just did above. Go ahead. Okay, I'm going to go ahead and stop you. I know most of you probably haven't made it to example 2, and that's okay. But I'm going to go ahead and stop you, and let's look at example 1. Okay, so we want to get the square part by itself. What is being squared here?
The X.
The X, right? Not the 3. If it wanted to square the 3 part, they would put parentheses around the 3x, okay? But in this case, that's not the case, right? I'm just squaring the x, so I need to get that x squared by itself. So I always start by adding or subtracting first, so I add 6 to the other side. I have 3x squared equals 6. And then this is 3 times x squared, so I just divide by 3 on both sides. And I get x squared equals 2. So I have isolated or gotten the square part by itself. Now how do I get rid of x squared? I square root it. So I square root both sides. Square root of x squared is x. The square root of 2 is 1.41. So plus or minus 1.41. Remember, every square root has 2 answers, so be careful with that. X equals plus or minus 1.41. Okay, let's go ahead and look at example 2 together. So if I am trying to do what I did above and isolate the square part, first I need to know what is being squared here.
The X and the 4.
The x and the 4. So x plus 4 is being squared. Okay, so I want to solve this by square root. So I need to isolate that first. What do I need to get rid of? Connor?
25.
The 25. So I'm going to do an opposite operation and add 25 to both sides. So now I have x plus 4 squared equals 25. So now I have the part that's being squared isolated. Now how do I get rid of a square? I square root. So I square root the whole thing. And I square root that piece as well. Don't ever, ever, ever distribute anything into the parentheses while it's being squared. Okay? Whether it be a number out front, whether it be the square outside. Don't ever distribute anything into the parentheses before you get rid of that square. Okay? So now the square root of x plus 4 squared, the square root of anything squared is just that anything. The square root and square kind of cancel each other out. So I'm just left with x plus 4. And what is the square root of 25?
5. Plus or minus?
Yeah, there we go. We got to get the plus or minus in there, right?
Wait, so if you square one side, you have to square both sides? Like you have to...
If you square root one side, yeah. If you square root one, because it's just like a regular equation. Anything you do to one side, you have to do to the other to keep it balanced, okay? So how many answers am I going to get out of this?
2.
2 from the plus or minus. So this is really like 2 equations, okay? So this is really like x plus 4 equals 5 and x plus 4 equals negative 5. So at this point, once I get rid of that square root, I'm ready to set up my equations and solve. Remember, if I have a plus or minus in my problem, I'm going to get 2 answers out of that, so I need to set up both of my equations. X plus 4 equals positive 5, and x plus 4 equals negative 5. Now I can go ahead and solve. So if I subtract 4 from both sides, I get x equals 1. And subtract 4 from both sides, x equals negative 9. Okay, so the only thing you need to remember is check and make sure there's one squared piece and no other variables. If there's one squared piece and no other variables, you can use square roots to solve. All you have to do is isolate the square, and then square both sides and solve whatever you have left, okay? All right, so I'm going to give you a little bit of time. I want you to work together in your groups, and I want you to do, let's see. I would like you to do A, C, and F. A, C, and F. Go ahead and do those three together with your groups. Go ahead. Okay, so on A here, I need to isolate the square. So I subtract, gotta get a pen. Subtract 1 from both sides. I get 2x squared equals 8. I divide by 2 on both sides. I get x squared equals 4. And then I get rid of the square by square rooting both sides. And x equals?
Plus or minus 2.
Attaboy, plus or minus 2, right? That's two answers, positive 2 and negative 2. All right, let's look at, any questions on A? All right, let's look at C. So I isolate the square. In this case, it's the 2x minus 3. So I subtract 20 from both sides. I get 2x minus 3 quantity squared equals 16. Take the square root of both sides. I get that 2x minus 3 equals plus or minus 4. Don't forget the plus or minus. So then that sets up my two equations. So I get 2x plus 3, or sorry, it's minus, isn't it? 2x minus 3 equals positive 4, and 2x minus 3 equals negative 4. So I add 3 to both sides. I get 2x equals 7. Divide by 2. I get x equals 3.5 or 7/2, whichever one you want to leave it as. Other equation, add 3 to both sides. 2x equals negative 1. Divide by 2. You get x equals negative 0.5 or negative 1/2. Okay, any questions on C? Those are the two main types, okay, is solving for just an x, solving for a set of parentheses. The rest is just kind of riff-raff. So let's look at F really quick. So I need to get the square part by itself, so I subtract 16 from both sides. And I get x minus 2 quantity squared equals negative 14. And I need to get rid of the square, so I square root both sides. Oops. And I get x minus 2 equals, what's the square root of negative 14? What?
Error.
Yeah, you can't square root a negative, right?
But it could be plus or minus.
So since I can't take the square root of a negative number, what's my answer here? No solution. Okay, so anytime you're trying to take the square root of a negative number, it's always no solution. Okay? So just keep that in mind. Just like with the quadratic formula, if I had a negative number underneath the square root, it ended up being no solution. Okay? All right.